In that case, -1. But if you are not writing the formula properly, then you have -2.
Yes, sir. I understand.
The next part is correct. Now 3. So here there is state and explain the advantage of heating the water from the below. It heats up the container faster as it causes convectional current quicker as density decreases and heavier water sinks down. So it is okay because you brought the idea of convection. They they
Yes, sir.
told in the mark scheme they highlighted like everywhere the water is heated uniformly. Hmm. So that is because of convection,
Oh,
right? That is because of convection. As you wrote convection, we can accept it. And by convection,
sir. So there will be no like minus marks because I
no,
didn't wrote the uniform part.
yeah, you wrote convection. That one is meaning that it is uniform. Okay,
Oh, yes.
convection is the process where the heat energy is transferred uniformly, right, by the circulation of molecules. Okay, then next one we have as the water is heated, it expands. Explain in terms of molecules by water expands. So the molecules of water starts moving faster, causing them to further increase the intermolecular space, which causes the water to expand. So here we got molecules move faster, molecules push each other far. Okay, this one we can accept what you wrote. And next,
Sir, for like in like main O levels, they will not exactly follow the mark scheme, right, sir? Like if it is acceptable, they will just accept,
yeah,
or like they will
actually,
like strictly
actually,
follow the mark
the
scheme.
the examiner has also the scope to apply the judgment. Yeah. So uh,
Or like he can change the mark scheme.
not change the mark scheme like if the students or the candidates are using some wordings or some ideas they are bringing, which one is quite similar to the mark scheme or closer to the mark scheme, then they can give you the marks. Okay, they have this standard that
Oh,
like not exactly you are writing the wording or the points directly, but indirectly you meant it. That one the examiner can
oh,
take.
yes, sir. Oh, okay.
Got it.
Yes, sir.
So copper also expands when it is instead what happens to level X of the water in the kettle. Explain your answer in terms of the expansion of copper in the where is level X? Okay. Actually, this one, the last one,
Yes,
you
sir.
wrote rises, right?
Yes, sir.
And Here we should mention something. Okay, you mentioned that liquid at leveling scale as the liquid expands more than yes, correct. You brought that idea also.
So, will I get the marks?
Yeah, yeah. Here you'll get the marks. Here you'll get the. If there
Okay,
is
sir.
any cut, I will tell you. Okay. So this one I will take. All are coming this way.
Oh my God.
Hmm.
Uh, Sir, while making the PDF, it like automatically rotates. What can I do?
Not during PDF. You when you are taking snap, you will see it that
Yes, sir.
it's coming like that. Okay. When just you're taking the snap, that time each of the photo
Uh,
you take is coming directly perpendicular or horizontal is coming. And if it is coming
yes, sir.
horizontal like this, then you take another snap of that. Okay. then
Okay, sir.
then this way maybe your number of pages will be more, but at least we will get the accurate one. If you get
Yes,
time, then
sir.
you can
Yes,
after making the PDF you can delete those pages which are horizontal, and you keep the
yes, sir.
pages which are okay, then you send
Mm.
me. This way you can do. It happens also when I make the PDF. That time also happens for me. That time I take a snap of each of the page double. Which one is like coming like that?
Okay, sir.
Automatically rotates. Okay, now here we have describe how to take that 100 centimeter in the correct position of, on the thermometer. Just put it on the boiling water, right?
Pure boiling water. Yes, sir. Sir, they gave 3 marks for this question.
Yeah, that's
So
why I'm checking
I
it.
wrote, yes, sir.
Yeah, for using of boiling water, 1 mark. Thermometer in boiling water, another mark. Mercury level at 100 degrees Celsius mark is another mark. So
Yes,
you
sir.
got it, right,
Yeah,
student?
yeah.
Then next we have state and explain how the maximum possible range of the ethanol in glass thermometer differs from the range of the thermometer in figure. Thermal expansion of ethanol is more than that of mercury. The maximum possible range of ethanol. So if expansion is more, then range will be less, right?
Yes, sir.
Yes, ethanol is more sensitive here.
Yes, sir. So, sir, will I get the 2 marks or will it be
Let's see.
minused?
Maximum possible range of ethanol in glass thermometer is less than the range is decreased, right?
Yes, sir.
Ethanol thread reaches the end at lower temperature.
So reaches the end at lower temperature.
That means uh, like the thermometer length we have here, right? Ethanol
Yes,
will
sir.
reach here. For example, ethanol is reaching at the end at 50 degrees Celsius, but the mercury one will go more. like 100 degrees
Oh,
Celsius or 70
for
degrees
the
Celsius.
identical thermometer, for like the same.
Yeah, they are actually talking about that one. Comparing both the liquids, it should be identical
Oh,
thermometer.
oh, yes, sir.
So that one you mentioned here, that one you say that at lower temperature, ethanol which will reach to the lower
Yes,
end of
sir.
the thermometer,
Yes, sir. At lower temperature, ethanol will
reach
reach
at the
the
end of the
ethanol
thermometer.
will reach at the end of the thermometer. Yes, sir.
So
So, sir,
here
my
you,
one marks will be
yeah,
deducted.
yeah, here one minus one you give, eh?
Yes, sir.
State what is meant by range. Range is
Yes,
okay,
sir.
but sensitivity, you write that one I told you, that is the
Yes,
increase of liquid thread by 1 degree Celsius, it is called sensitivity.
increase of liquid thread by 1 degree Celsius.
Hmm.
Okay, sir. So this is the definition of
Hmm.
the sensitivity. Okay, sir.
Five, right? 5A1. Okay, the next
So
one,
then,
state and explain one feature of the clinical thermometer that produces a high sensitivity. The narrow tube more sensitive, the thermometer becomes narrow tube allows the liquid to flow more due to small change in temperature. Okay, good. It's correct. You got here 2 marks. Both the marks you got.
okay, sir.
Then here, state the purpose of the constriction in the clinical. It does not let the molecule to flow back. Yes, correct. Explain in terms of mercury molecule how an increase in temperature produces an increased reading on the thermometer. In terms of the molecules, how an increase in chemical produces an increased reading, and the molecules start moving faster as the molecules. Yeah, it's like the previous one, right?
Yes, sir.
Now we
Yeah.
have to check that 3 points how it's coming. Yeah, they wrote molecules gain kinetic energy, they move far apart. You brought this idea, Mercury expands. Okay, all came.
Yes, sir. Sir, I wrote moving faster. So
Moving
kinetic.
faster, and you also wrote about expand, right?
Yes, sir.
And you
And
wrote they move far apart. You wrote that
yes, sir.
because you
Yes,
wrote
sir. I wrote.
increase the distance. That's why I took it
Yes.
as move far apart. So I can take it.
Yes, sir.
And then question number 6. You 1.7 into 10 to the power 7. 1.7 into 10 to the power 7. Electrical energy that is produced to this lamp in this time 63 hours and 75 watt. So why you converted it to 0.075?
So to kilowatt we need to convert, right?
No, what is
Kilowatt per hour.
you converted at the beginning to convert to kilowatt hour. Oh, see now. So convert to kilowatt hour. Fine. Then
Yes, sir.
4.725 kilowatt hour. Now, can you multiply it with 3600? Then 3600, then multiplied by 1000. Take what is coming.
So, so 3600.
Yeah,
Like,
multiply with 3600, then
so,
multiply with 1000. Take what is coming.
so 0.75 কি multiply করবো?
No. The whole answer.
70. Oh, 0.7. So we will multiply by what?
You will multiply by
1000.
uh, 3600,
Yes, sir.
then multiply
So,
by 1000.
then it will become 1702800.
That means 1.7 into 10 to the power 7, right?
Yes, sir.
So it's
Yeah.
correct. It's correct. Your answer
Oh.
is correct. You
But
can
sir,
accept
is my
this.
unit okay?
I think it's okay because kilowatt hour you wrote that is also unit of energy. Yeah,
Mm.
if you simplify it, it will come joules. The one I told you, that one is in
Yes.
joules, and it is
So for
same.
energy, like in these cases, we use the kilowatt hour, right, sir?
Yeah,
Like from electrical chapter. So like, sir, this is what is supposed to be, right? Uh,
yeah.
but
It's okay if you're actually in mark scheme they mentioned joules, but if you write this way, we accept it. No problems.
so like in the mark scheme, like
As
they
as your as
mentioned
your
both.
as your unit is correct, that's why there will be no
Yes,
problem.
sir.
But if you are writing here
Oh,
joules or any other unit, then it could be wrong.
yes.
You would lose mark.
Oh, acha, acha. Oh, yes, I got it.
Your
For
value
joules, we
and
need to
unit is
multiply
matching.
like, so for joules, we need to multiply watt into like seconds, right, sir?
Yeah, watt into seconds, correct.
Mm, yes.
Because watt is joule per second, then If you multiply,
Yes,
the
sir.
second will cut, joule is left.
Yes, sir.
So here you got your efficiency of the lamp is 0.12. Calculate the energy released by the lamp in the form of light. So your electrical energy you got there and its efficiency is 0.12, then it's only multiply with this one, right? And then you are getting
Yes, sir.
0.567. Yes, correct.
Yes, sir.
Then you are not writing the unit here. You should also write here kilowatt hour. Okay, because your previous
Oh,
unit was kilowatt hour. Here also write kilowatt hour.
okay, sir.
Okay. The power station that generates the electricity supplied to the office uses oil as the fuel. State and explain whether oil is a renewable or a non-renewable source of energy. Oil is a non-renewable source of energy as the oil will run out after usage. Okay, correct. Then discuss one environmental consequence. Discuss one environmental consequence of using oil as a source of energy. Burning oil may cause many greenhouse gases. These greenhouse gases contribute to the global warming. Yes, correct. Then we have calculate the engine internal energy. We have mc del theta. We got 6.8 into 10 to the power 5, right?
Yes, sir.
Should it be 6.8 or 6.9? Can you take in Maxim it's written
Okay, sir.
6.9. Maybe you did not take it to the nearest significant figures correctly.
So it's 6.8796
So if it is 87, if you write in two significant ways, it
Yeah.
should be 6.9.
Oh, so while taking in the standard form, should we also like
Yes,
estimate?
yes, yes. That time we are thinking this part has two
Yeah.
significant figures now.
Oh,
6
so like
point 6.9
related
should be there,
plan.
right?
Yes, sir.
Every time it should be correct. Eh? You check
Yes.
it always. And
Okay.
for this one, you are losing mark.
Minus
It's
one.
written answer mark only. So A1,
Okay,
this
sir.
one you are losing one mark.
Okay,
If
sir.
it is not exact answer, then you are losing mark. Here the examiner cannot show judgment. This is answer mark.
Okay, sir.
Then suggest why it takes more time for the temperature to increase from
Hmm.
as more work is needed to be done between the molecules as the spacing increases and they already further so why more time needed is actually uh, in surrounding area some energy is lost, right?
Yes, sir.
So the amount actually required, that one you are giving and something is lost, so you have to give more, right? It's the
Yes, sir.
reason, is the reason, main reason, huh? So you add here some because some energy is lost in
Hmm.
the surroundings.
Some energy is lost. Sir, How it is lost to the surroundings?
Like you are giving heat, right?
Yes, sir.
Now, if the condition was like that, that no energy is lost in the surroundings, then, for example, for raising this temperature 23 degree to 49 degree, yeah, you or 49 to 75
Yes,
degree, the amount of energy you require, that amount of energy, maybe you require 50 joules, right? But as some energy is
yes,
lost
sir.
in the surroundings, now you have to give like 20 more joules, right?
Oh, yes, sir.
So that's
So,
why
like, energy is lost because, like, it is like exothermic. It's
yeah,
happening,
yeah,
right?
yeah, correct, correct.
Mm.
So in surrounding areas, some energy is going, right?
Yes, sir.
So it's clear now.
Surrounding. Yes, sir. Now it's clear. So, like, but my both of the points are like covering, right? That
You,
part.
yeah, you wrote
Because,
as more work is needed to be done between the molecules. You brought the idea actually internal, actually the energy required normally or naturally, or which one is actually needed. That one you mentioned. You did not
yes, sir.
bring the idea why we need more energy. More energy is
Oh,
needed. It's for loss of energy, right?
oh, now I get it. Because energy is being lost, so more energy is needed.
Yeah,
Yes, sir. So I will get -1 only.
yeah, yeah. Okay, now this one
Yes,
explain
sir.
how thermal energy is transferred from the heater throughout the water. The molecules gain kinetic energy and start moving faster. So you are saying molecules gain kinetic energy of what? Heater or water? Which one?
The it's a heater.
Heater. So
The,
mention it. Molecules of
oh,
heater gain kinetic energy because we are getting two steps here, right? First
yes,
there
sir.
is conduction, then there will be convection, right? So we should
Yes,
bring
sir.
those idea clearly and uh,
No,
specifically.
sir. So the heater is in the water, so like it is not going through the steel.
Yeah,
So it's like directly
listen,
going to the water.
listen.
Yes, sir.
First you are getting the heat in the heater, right? So
Yes,
this
sir.
the molecules is staying in heater. Uh, that one first gain energy, right? And they start vibrating,
Oh,
and they are transferring this energy to the water molecules, right? So this
yes,
one
sir.
is conduction. First, this one is happening. That is conduction. Your convection will be only in liquid
Yes,
or only in gas.
yes,
Okay,
sir.
but from liquid to solid or solid to liquid, that one is conduction. Is it clear?
Yes, sir. Yes.
Now let us check.
So there'll be -1.
Oh, wait. I'm not saying you to give -1. I just said you
Oh,
that point. Okay.
oh,
Okay. Now we check. When heated, water expands. Volume of water increases. Water becomes less dense. Uh, yeah. Heated water rises. Cooler water sinks down. there is circulation or convection current. So uh, actually they are directly asking you the water one, how the heat is transferred
Yes,
in
sir.
water, right?
Yes, sir.
So molecules gains kinetic energy and start moving faster. Therefore, the distance between the molecules increases and their density decreases. The lower dense water goes up, higher dense sinks down, causing a convectional current. Yes, correct. So you got here 3 marks, no problem. Then next,
Okay, sir. So next is the through the steel they are asking.
yeah, the part of the boiler that holds the water is made from steel. Describe in terms of how thermal energy passes through the steel. In steel, the particles gain thermal energy and they start vibrating vigorously in the fixed positions possible. What you read? Passing energy to the neighboring particles.
Yes,
The
sir.
electrons also go from a hotter side to colder side, passing the thermal energy. Yes, ideas correct. Let's see. Points are coming all or not. Atoms, molecules, particles vibrate, collide with neighboring atoms. Yes, energy, heat, vibration. Yes, correct.
Okay, sir.
Okay, then C3. State and explain in terms of particles what happens to the density of the steel. As the temperature increases, the density remains same. Even though the particles vibrate, they do not increase the kinetic energy so much that they end up breaking the bonds. Density of the steel.
Sir, the steel's density does not change, right? Because it is a solid. But if it was water, the density would have changed.
Little bit there will be, we have also the metals. They
Yes, sir.
their volume also increases. The metals or the solids one also we see sometimes their volume is also increasing due to the heat energy. It's because it's not like the gas or liquid slightly increased, right? The volume,
Yes, sir.
and it's
Yes.
because particles, molecules, uh, due to the vibration, they are little bit
No,
far apart.
sir,
Yes,
they are talking about the density. So the
yeah,
density will remain same.
yeah, that one I'm bringing you idea. It's
Okay,
not
sir.
that much, little bit, huh? Little bit, the
Yes,
volume
sir.
will increase, but your mass will never change, right?
Max will stay same. Yes, sir.
Yeah, mass will always be same. Your volume is slightly increased, isn't it?
Yes, sir.
So if your volume is slightly increased, then density decreases slightly.
Slightly. Yes, sir.
So that idea you
Decreases
bring
slightly.
here. So you first write that
Yes, sir.
particles, molecules, little bit move move far apart due
Hmm.
to vibration.
Little bit move far apart due to vibration.
Vibration, yeah. Then volume slightly increases,
Yes, sir.
hence density slightly decreases.
Yes, sir.
Got it?
Yes, sir.
So
The density slightly decreases.
yeah, it's clear now.
Yes, sir.
Now we are going to next one, 9.
So, sir, this will be -2 or like -1.
Okay, let me check
That's all.
density. Oh, here we will actually we see that you brought that density remains same, so it is wrong. And
Yes,
particles
sir.
vibrate, they do not increase the kinetic energy so much that end up. So it's not getting marks. Huh? You should bring that idea a little bit. They move little bit far apart. As they have more temperature, they will they will have more kinetic energy, right? Isn't
Yes,
it?
sir.
So
Yes, sir.
if they have little bit even moving farther apart, then they will have
Yes, sir.
volume increase, and due to that there is density decrease, right?
Yes, sir.
So here minus two will be appropriate here.
Oh, so -2. Okay, sir.
Okay, now this one we have, you
Yes, sir.
got 10 to the power 7, right?
Yes, sir.
Correct,
10 to the power 7.
correct. Your answer is correct. Then you wrote chemical energy changes to kinetic
Yes,
energy.
yes, sir.
Chemical to
Yes.
thermal energy.
Mhm.
Chemical to thermal energy should be the answer.
Chemical to thermal energy. So
The,
it will be
you see
minus
the
one.
question, it will be
Yes, sir.
-1. Instead, the energy transfer that is taking place when the ship is traveling at constant speed. So, uh,
Oh,
after at the final stage, it's the kinetic energy is converting to thermal energy, right? Because of the friction with the water.
yes, sir. Yes, sir.
So your deceleration is coming 0.0127. 0.0127. Yes, it is correct. Now we have, as the speed of the ship decreases, the deceleration decreases. Suggest and explain how the deceleration changes. The deceleration increases as the speed decreases. The change in speed is decreases. Deceleration decreases, then your what you rate, then decrease as deceleration
Yes, sir. So
deceleration.
is it okay?
Um, you let me
So the
check the as
idea
the
is,
let me
yeah.
check again. Okay, as the speed of the ship decreases, if the speed decreases, then resistive force also decreases, right?
Yes, sir. The air resistance or the water resistance, like
Yeah,
that,
resistive
right, sir?
force decreases.
Yes, sir.
So if resistance decreases, then uh, deceleration, how the deceleration will increase?
Because this, because by
Like
the formula
your
we know the change of the velocity by time, right? So
Yeah,
like
yeah.
if it decreases, the change will decrease, which will end up decreasing the deceleration.
Okay, so again, I'm saying you the one I said before. Like if
Yes,
your
sir.
if your speed is decreasing, then your resistive force is decreasing, right?
Yes, sir. Yeah.
So if you think of about the deceleration comes from the resistive forces, isn't it?
Oh,
The more
oh,
the resistive force is working, your deceleration will be also more, right? Isn't it?
yes, sir. Yes, sir.
So your one idea you have
Yeah.
from there, if you come to the other idea, then it comes that deceleration decreases, right?
Yes, sir.
Deceleration
This is
decreases
decreasing.
as the resistive force decreases
Increases.
with the
Or
speed
decreases.
decrease. Okay,
Mm.
this way you write.
Yes, sir. Deceleration decreases because uh,
As the
in
no, you write
as the
deceleration decreases as the resistive force decreases
yes, sir.
along with speed decrease.
Mm.
So what
Yes,
you
sir.
wrote?
Then it will be -2
Yeah, what you wrote?
because
What you
I
wrote?
wrote deceleration increases as the speed decreases. The change in
No, no.
speed is
Now
decrease.
what you wrote now? The deceleration decreases as the resistive force decreases.
Force decreases along with the speed decrease.
Okay, okay. That one should be the answer. Now we check mark scheme has written deceleration
Yes, sir.
decreases, resistive force decreases, or resistive force depends on speed. So here you will get -2. Huh?
Yes, sir.
Okay, then next on figure 9.2 is sketch a possible speed time graph for the ship as it decelerates to rest. Okay, so it's from 9.7 to uh,
Yes, sir.
yeah, we have 0, speed is 0, and time, there is no time mentioned here, just
Yes,
uh,
sir.
typical diagram you do there, right?
Yes, sir. Like only right, sir.
Why you gave here straight line? Did you get here
Because
constant deceleration?
no,
Here you got
distortion
deceleration
decreases.
decreases, right?
Yes, sir. Yes.
So if you get deceleration constant, that will be straight line. But now you
Oh,
will get a curved line with decreasing
yes,
gradient,
sir.
right? As your deceleration is
Yeah.
decreasing.
Yes, sir. So, sir, how should it be?
So it should be, I'm showing you, wait,
Yes, sir.
decreasing gradient, right? Curved line with decreasing gradient.
Yes, sir.
From here you start,
Yeah.
then you draw like this.
Sir, like curve.
Curved line, curve.
So, will it be like touching the surface? No, time
Yeah,
axis.
this they are saying rest, so you should touch the time. Without
Oh,
without the touching time, it will not be speed 0, right?
Yes, sir. So, sir, it
Sorry,
should
sorry.
be
It
like
should be smooth curve, right? Smooth curve. My
yes,
drawing
sir.
is not perfect. That one. You should draw this way, smooth curve. Okay.
Yes, sir.
It will not be upside down. It will be smooth curve. Okay. This way.
Okay, sir.
You see here
Yes, sir.
decreasing gradient. Curve line with
Yes,
decreasing
sir.
gradient. So here you give minus.
-1.
Let me see. It is -1 or -2. According to, okay, then you give here -1 because for decreasing
Okay,
gradient
sir.
it's
Yeah.
giving, no, it should be -2 because there's a gradient
Oh,
decreasing. Your
yes,
gradient
sir.
was constant there, right?
Yes, sir.
So it should be -2.
Okay, sir.
Then next,
Yeah.
explain how the distance traveled by the ship may be determined from the speed of
Yeah.
calculate the area under the graph. Yes,
Yes.
correct. This one is correct.
Okay.
With the area mentioned, area under the curve, marks. Okay.
Okay.
State a relationship that defines efficiency. It is the ratio of useful energy
Yeah.
output by total energy input. Correct. Calculate the ratio at which energy is wasted in the engines. Ratio.
Yes.
Oh no,
Oh.
rate.
Oh.
They are saying rate.
Wait. Wait.
Energy is wasted in the engines. So if your energy is wasted,
Yes, sir.
then you have here efficiency is 0.35, right?
Yes, sir.
0.36. So you
Yes.
got here uh, 0.36 multiplied by 33 megajoule per second, right?
Yes, sir.
Rate at which energy is wasted megajoule per second, you write. This is actually
Yes, sir.
your useful power output you showed.
Oh.
That
Sir,
one
then it will.
minus 1 minus
Yeah.
0.36, that one is wasted 64%.
Yes, sir.
So that with that one 64% you should multiply, that will give you the energy wasted.
Oh, like 64%. How you are understanding 64%? Because 100 minus 36.
Yeah, because efficiency is given 36, that is useful one. The rest part is wasted
Oh.
one.
Oh. Okay. Yes, sir. So it will be 0. So sir, it will be
0.64.
0.64
Yeah,
into
into
33. Then
yeah. That will come 21 megajoule per second.
yes, sir. 21.
Yeah, so here you get -2.
Yes, sir. Yes, sir.
Okay, then next we have next question we have here. Okay, then describe how this energy is produced in the sun. The hydrogen nuclei in the sun
Yes, sir.
fuse together to form helium nuclei. Therefore, this energy is produced from fusion. Okay, then state how this energy is transferred to radiation. Explain why solar panels are usually black. They are good absorber, and therefore it can heat more efficiently take the heat energy. So last part
Yes, sir.
is a good example radiation thermal energy. Yeah, they are accepting here for
Mm,
like they are absorbing heat energy more, right?
yes,
Efficiently heat
yes, sir.
energy more. That's why they are taking these two
Yes,
points. And
yes,
next one, describe in terms of ways in which gas differs from a liquid. Gas
mm,
have more kinetic energy of their molecules compared to liquid gases. Gases has a less intermolecular force. Molecules in gases are
yes, sir.
farther apart.
Yes,
In order to keep the liquid boiling, it is necessary to keep the hot plate switched on. Explain why energy must be
yes,
supplied in order to turn a liquid is boiling point into a gas. Boiling molecules are within.
yes, sir.
Okay. Let me check both together. Okay, done. So this one you got full marks. Okay.
Oh, okay, sir.
Okay. Then you count how many minus marks are there.
Yes,
You
sir.
count and
Yes, sir.
go to the first page and write there, the percentage also.
Okay, sir. Sir, I got 55.
55.
Yes, sir.
So 55 out of 75.
Yes, sir.
Okay, write there
So,
55 out of 75. Then percentage you get
yes, sir. Sir, I get 73%. 73%.
73%. 73%. Okay, write the date, today's date there.
Sir, yes, sir.
27/11/2020.
Yeah. Yes, sir. So, sir, will I like see the total marks?
What?
The total marks
I
of
don't
like paper
understand.
one and paper two.
Yeah,
Sir,
yeah.
paper
You
one
you
and paper
just
two.
you just take the snap and send me
Yeah.
the first page, cover page in our in my messenger. Okay,
Okay, sir.
there you send.
Sir,
Then I will get it. Okay.
okay, sir.
Thank you. So our next one is waves, right?
Waves.
Four
Yes, sir.
topics. Topic 13 to topic 16. Revise them, huh?
Yes, sir.
General
Okay,
wave
sir.
properties, then light, then after light we have electromagnetic,
Sound.
electromagnetic spectrum, topic 15,
Yes.
and we have topic 16, sound.
Yes, sir.
Okay, four topics. I will give you the MCQ part on Sunday, huh? Inshallah.
Okay, sir.
And
Inshallah.
Tuesday,
Okay.
like before, structured. Thank you.
Okay, sir. Allah
Allah
Hafiz, sir.
Hafiz. Assalamu alaikum.